Welcome, everyone. We're going to go ahead and get started. Welcome to the What to Look For, Pests and Diseases of Specialty Crops. This is a webinar hosted by the Center for Crop Diversification at the University of Kentucky Cooperative Extension Service, part of the College of Agriculture, Food, and Environment. We have three great speakers today, three extension faculty members from the departments of plant pathology and entomology. We have Dr. Rick Besson, Dr. Nicole Gauthier, and Dr. Emily Pfeiffer. And they're each going to be sharing a little bit of a different perspective on this main topic of pests and diseases of specialty crops. I have a couple of goals I would like for you all to take away from this webinar. First is to hear the content that they have to share. These are experts in their field who are able to share based on experience, what they've heard, questions about, etc. They're able to share some tips and pointers and overviews. But additionally, I hope you'll pay attention to the additional resources that they share, links, etc. We'll collect all those links and put them together into a package that we'll email out to you. And the last one is, if you haven't already, I hope that you'll consider establishing a relationship with your local extension office. I think that'll be a common theme from all the speakers, that's really that first point of contact for the growers on the ground is that local extension agent. And then they can tap into all the great things that these folks are going to be talking to you about. At the end of the talk, we'll give out a survey just to give an overview of your impressions of the talk, and we'll give that link toward the end. So thanks to the University of Kentucky and Kentucky State Cooperative Extension Service, and additionally a big thank you to the Kentucky Department of Agriculture, and specifically the Specialty Crop Block Grant Program, which provided funding for this and other initiatives that you'll see through the Center for Crop Diversification. So this webinar coming to you through their support. So a big thank you to them. So I guess we can go ahead and start. Rick, if you want to go ahead and start, share your screen, and we'll start with you.
Okay, can you hear me? All right. No one told me that they cannot hear me. Did I just lose everyone?
We can hear you. We can hear you here.
For some reason, I can't see my screen right now. Can you see a PowerPoint screen?
Yes.
Okay, and it says Specialty Crops Entomology Online Resources?
Yes.
Okay, very good. Okay, let me go ahead and get started. So my name's Rick Besson. I'm an extension entomologist, and I work with specialty crops here. I have about 15 to 17 minutes to cover the common pests and how to monitor for them and the resources we have for fruit and vegetable crops. So I'm going to go through this fairly quickly. Here on this first slide, the one thing I wanted to point out are the resources that we have available. Again, these are only a few mouse clicks away for you. But, you know, one of the first things I bring up is our entomology fact sheets. We have literally 400 to 500 fact sheets that are available. And, you know, how I would recommend using these is when you have a particular problem, it's good to review these fact sheets. And then when you have some questions, go to your county agent. And now you're talking from a higher level. You know, you've been exposed to the pest biology and some other things there. We have some other websites on invasive pests and their establishment within the state. We have a series of IPM scouting guides for specialty crops. We have close to a dozen of these now. We have some older scouting manuals for some of the common vegetable crops that are also available. I recommend that you keep track with the Kentucky Pest News that has timely articles about pests and pesticides and diseases and things like that. We have some of our insect weather models are up on the Ag Weather Station website, and this is how you can predict certain stages of insect development. Our commercial vegetable spray guide, we refer to that as ID 36, is online if you don't have a printed copy. Our commercial fruit spray guide is also online. This is in Kentucky what we call ID 232, but Purdue is the one that posts the PDF on this. The pesticide safety education website is very important. Anyone that's selling any type of produce that enters commerce and you spray it with anything restricted or private use or restricted use materials, you need to be a certified applicator. Pesticide label database, again, the link to CDMS. This is one that the specialists use an awful lot. And lastly, for spotted wing Drosophila, which I'll be referring to, we have a Facebook site to keep up with that pest. So the specialty crops I want to cover today, I can't cover everything. Tomatoes, peppers, melons, squash, and sweet corn in the vegetable group, apples, peaches, blackberries, and blueberries in the fruit group. One of the first groups of pests I want to mention are stink bugs, because stink bugs really attack all of these. They attack most of our vegetable crops, all of our fruit crops. They're very serious. They're active from May through September. Some of these overwinter in structures. They're tough to control with insecticides. We're either using some of our broad spectrum pyrethroids, or we're using some other materials specially targeted to control these stink bugs. They do move from crop to crop. Many people growing specialty crops on their farm are growing a diversity of crops. And so they, as crops become susceptible from week to week, these stink bugs can move around on the farm. And we do have 1 or 2 generations per year. I do picture some of the common stink bugs we have in Kentucky there, the brown marmorated. We have 2 species of brown. We have the green stink bug. I also show some of the damage that you should be familiar with, you know, when you're going out and monitoring your fruits and vegetables. But these guys feed with piercing, sucking mouth parts, and they suck juices out of the plants while injecting enzymes. And you get these discolored, corky areas often underneath the skin of the fruit. And that's a telltale sign that you have some stink bug damage. The one thing I want to mention about vegetable pests in terms of monitoring is that most of our pests in vegetable crops, we monitor them, you know, by getting down on our knees or flipping over leaves. You know, you can see this is a picture of a county agent and how he's using a hand lens to find and identify some of these pests. I mean, that's our basic strategy for most of our pests. There are a few of our sweet corn pests, like corn earworm and fall armyworm. We use that tall, what we call a cone pheromone trap. We also have some traps for diamondback moth in cucurbits, as well as brown marmorated stink bug. In high tunnels, we commonly use these yellow sticky cards, and this is one of our key monitoring tools, along with visual sampling of the plants that we use to monitor for pests. So let me just start with the first crop. In high tunnels, tomatoes in the high tunnel, we have several species of whiteflies, and I list these first because they're some of the most common pests that I deal with in the greenhouse on tomatoes. We have the silverleaf whitefly and the greenhouse whitefly. They're always going to be on the undersides of leaves, and one noticeable sign that you have a serious whitefly problem might be the honeydew that they produce, and it drips on lower parts of the plant, and that's you might get some black sooty mold. You might see some of their cast skins are getting stuck to this honeydew, but that's a tool I use when I walk through a greenhouse. The number 2 group that I have would be thrips, and thrips are very small. They're only about 1/20th to 1/25th of an inch. You really need a hand lens to identify them. But when I'm going through a tomato greenhouse or a high tunnel, what I look for is that picture down in the lower right, where you see some of those brown patches on the leaves. And I look to see if there's some of those tar spots, which is the waste material left behind that's adjacent to those brown spots or on top of those brown spots. That's a common indication that you might have thrips in the greenhouse. The other pests I see in the greenhouse on tomatoes would be aphids. We have several species of aphids, but also mites. They're not really insects, but they fall into the entomology group. You know, spider mites can be very common. If you look at that one picture in the upper right there, you can see some of the characteristic stink bug damage, what we call stippling of the leaves, little tiny yellowish spots on the leaf. Down below, I show a picture of russet mites, which are extremely small, and some of the common damage I look for in the high tunnel, which is, you can see in the background that bronze stem. You know, tomato stems should be green, but this one's turned bronze, and you see the fruit sort of have a leathery bronze appearance as well, and that's why they call them russet mites. This is a pest you need to catch early because it spreads like wildfire within the high tunnel. In the field, when we grow tomatoes, we see very different types of pests. We're not seeing the white flies, we're not seeing the thrips and things like that. We tend to see a lot of caterpillar problems and stink bugs and leaf bugs. And so the stink bugs I mentioned earlier all can attack the tomatoes. That other one that I have in the upper right there is also common in some years in field tomatoes, and it's a leaf-footed bug. Here I just called it a leaf bug, but it causes the same type of damage as stink bugs, and they can be difficult to treat. And so you would actually select insecticides for stink bugs to attack this insect. Down below, I have a picture of a yellow-striped armyworm. Yellow-striped armyworm and corn earworm, which is also called the tomato fruitworm, are the other common ones that we see in field tomatoes. And they're attacking the fruit itself, and so we have a very low tolerance for these guys. And again, the spider mites that I showed earlier are also a problem in the field tomatoes. In terms of tomato resources, we have scouting guides, one for the high tunnel, one for the field, and we have a number of fact sheets that are also available for various pests of tomato. So the next group I have would be peppers. Peppers are a very common crop here in Kentucky. Again, the stink bugs that I mentioned earlier are probably our #1 pest of peppers. Number 2 would be the beet armyworm. We see that in some years. It is a sporadic pest, but when it does show up, it's a very, very serious pest and can build to very high numbers pretty quickly. You can see what the beet armyworm larva looks like. You recognize it by a black spot over the second true leg, and you can see the damage they cause to peppers. That the little small holes in some of those younger leaves is a characteristic sign of beet armyworm. The other pest is broad mite, and we are seeing that more frequently these days. And down in the bottom right, you can see what it looks like. It almost looks like virus or herbicide damage to the plant, but that's actually a toxin that's injected with the saliva of the broad mite, and it doesn't take many broad mites to cause that type of damage. So for peppers, again, we would use the same solanaceous guide to help identify some of these pests. We have a number of fact sheets. Again, these are all available on the Entomology website. Let's just keep moving. We don't have a lot of time. The next crop I just wanted to mention would be melons. So you could also put cucumbers in this group. The key pests that we really are concerned about are the striped and spotted cucumber beetles. And you can see a picture of them up there. They're about 1/4 inch long. Generally, as soon as you put your plants in the field, they will be attacked by these beetles. Sometimes they even come into the greenhouse and attack the transplants that are being grown for the field. Not only do they damage the plants, but they can vector a bacterium that can cause bacterial wilt of cucurbits. The other pests that we see on occasion in melons would be spider mites. And so it's a 2-spotted spider mite. And again, that doesn't happen very often. A lot of it is weather dependent if we have a very hot, dry summer, but that can show up as well. For squash, we have some different pests. Not only do we have the cucumber beetles that are as important as they are with the melons and cucumbers, but we also have another pest called the squash bug. And I would say I probably get more emails and phone calls about this pest than I do any other vegetable pest. That they can build up to very high numbers late in the season. late in the season, they can be incredibly difficult to control. So a lot of our control is targeting early in the season when the plants are small. It's easier to get good coverage with our insecticides. But you can see the different stages. We have the adult that overwinters, it lays the eggs. And then late in the season, you can see how the populations can build up, and you get these grayish, they almost look waxy nymphs that can be covering the lower portions of the plant. Another pest that we have to watch out for in our squashes would be squash vine borer. This pest over the years has been increasing in number. It's a small moth that lays eggs singly, and then those eggs hatch and the larva tunnels in the vine of the plant. And you can see what the adults look like. They're actually a paper wasp mimic. And they're active generally from mid-June through the end of July, or a little bit beyond that point. Again, we're going to try and control these before the larvae bore into the vine. Once they're in the vine, there's little we can do. In terms of resources, again, we have a number of fact sheets. We do have a scouting guide for all of the cucurbit crops, so that's available as well. The next one I wanted to mention was was sweet corn. This is our largest acreage vegetable crop. Really, there's two pests that are common. The corn earworm is really our primary pest there. That lays eggs on the silks. The eggs hatch. They tunnel in following the silk channels into the ear, and it can be very damaging. One thing to note is the variable color we see with the corn earworm. And so they can range from green to yellow to black to red and pink and gray and all the different colors. This is the one we generally are targeting our sprays for during the silking period. While the silks are fresh, a lot of commercial growers may have to treat every 3 to 5 days to keep the corn earworm out of the ear. Fall armyworm is a less common pest, but in western Kentucky in particular, it can be more common and can cause similar damage. The one thing you need to note with fall armyworm is it will also feed in the whorl of the plant, and you get a lot of that ragged feeding in the whorl as an indication that you have fall armyworm. In terms of resources, we have a scouting guide for sweet corn. And again, we have a number of fact sheets that are available online. Let me jump over to the fruit crops. Here, much of the scouting, again, is going to be flipping over leaves and visual inspection of the plant. We also are using pheromone traps, and I've listed the insects that we commonly use pheromone traps for below. Codling moth, Oriental fruit moth, peach tree borer, lesser peach tree borer, spotted winged Drosophila, and brown marmorated stink bug. The one thing you have to get skilled at when looking at these pheromone traps is you actually capture a lot of insects. And so you have to get good at identifying some of these pests when they're covered in tanglefoot and stuck to the cards, as you see in those pictures. So let me start with peaches and apples, some of our key pests. The three that we really design our spray programs around in apples would be plum curculio, codling moth, and Oriental fruit moth. And plum curculio has a single generation per year. They emerge, they mate, and then when the apples and peaches are very small, the female cuts these little crescent-shaped wounds in which she lays an egg. And so you can see that on the young fruit. Doesn't look too bad when the fruit are small, but you can see when that apple grows throughout the season, you get these large blemishes on the surface of the fruit. But again, it's a single generation. It's usually 1 or 2 sprays in the spring, and you take care of the problem. Codling moth is one of the worms that goes to the center of the apple, and no one wants to see a codling moth in the apple. This insect in Kentucky has 3 generations per year. Again, we spray preventively when we know they're active. We'll put the sprays on before the eggs hatch. If you're having problems, you can see that one evidence that I have of damage there when you look at the blossom end of a developing apple and you see that, you know, almost like coffee grounds coming out the tip of the apple. We call that insect frass. That's their waste material, and that's evidence that you have a codling moth or an oriental fruit moth larva that's tunneling in the apple. The third one I have is the oriental fruit moth, very similar to the codling moth, in the same genus. The big difference is this one has 7 generations per year, but the larva will also tunnel right to the center of the apple, just like the codling moth. And so some of our orchards have more codling moth problems, some of our orchards have more oriental fruit moth problems, and they'll run pheromone traps based on the presence or absence of these moths. We have a lot of resources online, so we have a number of fact sheets on how to manage some of these pests. We also have the color IPM scouting guide for apples that is available as well. In terms of peaches, there are a few other pests, so not only the ones I just mentioned, but these are in addition to that. San Jose scale. Peaches are very, very susceptible to San Jose scale. San Jose scale injects a saliva that's toxic to the plant, and it can kill limbs or kill trees. And so you can see with the San Jose scale, when you peel the bark back, you can see the damage to the wood from that saliva underneath. Peach tree borer is also a problem, as well as lesser peach tree borer. And so these will actually, the larvae will tunnel underneath the bark, and they can damage trunks and scaffold limbs, or potentially even girdle some of those if it's very severe. Gummosis, again, gummosis is that sort of that jelly-like plant sap that comes out and hardens on the outside of the bark. Again, if you see some things that look like coffee grounds inside that gummosis, that's an excellent indication that there's a problem with either lesser peach tree borer or peach tree borer. Both of these growers will run pheromone traps for and treat accordingly. Again, some additional fact sheets that we have for peach insects. We're hoping to have a scouting guide next year for peaches that will be available. In terms of blueberries, really the #1 pest that we have right now is the spotted winged Drosophila. This is a new invasive pest. It's come in. It's been a real game changer. You know, in the past, many people growing blueberries did not have to spray insecticides. You know, there was some small amount of damage, but it wasn't that serious. This insect can potentially be very damaging in certain situations in certain years. And so growers may monitor for this and treat accordingly. But when they do have to treat, it's going to be during the harvest period. It's when those berries start to turn color that they become susceptible to the egg-laying damage. What we want to avoid with spotted winged Drosophila is having the live larvae inside the fruit, and the fruit that goes to our customers, because you can ruin customers very quickly when you have something like that. To a lesser extent, we have Japanese beetle, and that can be a problem with the blueberries eating the fruit. In terms of blackberries and raspberries, again, the #1 pest by far is going to be the spotted winged Drosophila. Blackberries and raspberries are our most susceptible crops. We've done some counts, and we have seen 10 or more larvae per berry in blackberries. So they can be very heavily infested with these larvae. Again, the same things that I mentioned with blueberries would apply to the blackberries and the raspberries. Japanese beetle can be a very serious defoliator of both raspberries and blackberries. They like getting up high on the canes and chewing the leaves downward on the plant. And what I haven't mentioned before is green June beetle. And this one, again, is a fruit feeder. And a lot of times growers may be spraying for this or using netting to keep the green June beetle off the plants. In terms of resources, we do have a number of fact sheets, particularly those with spotted winged Drosophila. We're hoping to have a scouting guide out later this year. And I know that was very quick, but I did exceed my time with this. So any questions?
If you have questions, go ahead and put them in the chat box. If you look down at the bottom of your screen, you should have a little bubble that looks like a talk bubble. It says chat. You can leave those, and you can leave them through the course of these talks, and we'll try to answer as many of them as we can. Nicole, actually, if you want to go ahead and start sharing your screen, one of the things that I'm, as we're sitting here listening, I'm realizing in addition to the wide variety of crops that folks are covering, there are also a wide variety of different types of producers. And so if you're feeling overwhelmed by the amount of information, if you feel like you're a smaller grower and you aren't quite ready for this amount of information, or you can't take it in all at once, we'll make sure to get this to you. But again, taking a look at some of these online resources, and also getting in touch with your local extension office, you can approach this as quickly or as slowly as you need to based on your operation. This is just kind of an opening to this conversation, and I'm hoping that some of you are learning about things that you haven't heard of before, or maybe just re-emphasizing the things that are available.
Okay, I can't share until Rick unshares.
Okay, how do I unshare?
Hover down at the bottom. Remember where the share screen, it should say unshare screen or stop sharing.
Well, it disappeared on me. Let me just log off and I'll come back or something.
Okay.
Oh, all right. There we go.
All righty. So here we go. All right. Are you all blacked out, or my screen coming up?
We can see it.
You can see it. Okay, it disappeared for me. All right. He gets us, I swear. All right, today I'm going to talk about strawberry diseases in particular. So I am the fruit specialist, and the more I thought about this, the more I figured that trying to cover all fruits at one time might not be my best bet, because there's not a whole lot of overlap. So I'm going to cover specifically strawberries today. I'm going to go pretty quickly. I'm going to target about 6 diseases of strawberry, but even if you don't grow strawberry, there's still some basic disease management folded in here. So, and any other questions you may have or any other resources, we're very happy to share. So let's get started. The most common diseases of strawberry, in fact, listed here, the top 6 over the last 10 years here in Kentucky. So I did a kind of a background summary. I'm dividing today by leaf diseases, fruit rots, and then root and crown diseases. So I'll go through those one by one. Foliar diseases or leaf diseases, the 2 most common are leaf blight and leaf spot. Blight means kind of quick death, and spot, of course, means spot. I'm not really touching on leaf scorch. Sometimes, though, these leaf diseases can get a little bit confusing. Leaf blight, first of all, is caused by a phomopsis. It starts out as small spots on the leaves, usually around the edges, and usually pretty early in the season. They're usually kind of purple, and then that center gets kind of ashy colored. They darken, they enlarge, and you'll see the photo on the right, that wedge-shaped lesion, or that V-shaped lesion, very classic of the phomopsis or the strawberry leaf blight. And the photo here on the left, you'll see those structures, those little black dots in the middle of that lesion. Those are fruiting structures called pycnidia. And inside each of those fruiting structures are fungal spores. You can usually see these fruiting structures with your eyes. You can't see individual spores, but these are capsules, if you will, that are full of spores. Phomopsis or leaf blight, usually you'll start seeing it in summer and fall. So this is a post-harvest. Infection occurs earlier in the season, but you'll start seeing this dieback and this blighting a little bit later in the season. That matters because the way we manage disease is all based on time of infection, not time of symptom development. So if you learn anything today, even if you're not a strawberry grower, infection is different than symptoms or disease. Disease is a symptom. So infection can occur days, weeks, months after infection. Okay, so let's get back to this particular disease. Usually we see a lot of phomopsis when the weather is wet, when the rainy summers just kind of linger on and on. That's pretty common of when we'll see this leaf blight. This fungus will build up from year to year, in particular if you are in a perennial strawberry system like a matted row. If you are an annual strawberry producer or a plastic culture producer, it's not that likely that you'll see leaf blight, because this is one that builds up year after year. In fact, these disease leaves and those little capsules that you see how they're black and they're hard, and that's a survival structure. So that's the structure that overwinters and will build up in soil. Oh, it won't build up in soils. Let me backtrack. It will overwinter in soils. So year after year, you can see buildup. So the more severe, look at the picture on the right. Imagine the number of those overwintering structures that are on that plant alone, and then overwintering, especially in a matted row system. Then the next spring that those fungal spores are ready to infect again. So think about overwintering in the infected plants, in infected fallen leaf tissue. That's where we see the most severe cases when we do have that opportunity to overwinter. So how do we manage this strawberry leaf blight? Sanitation, first of all. We're cleaning things up. We're cleaning up diseased leaves. We're cleaning up diseased plants, pruning them back. If you have a very small operation, it's much more easy to do that cleanup step. We're planting resistant cultivars when we can get our hands on them. If you're in a plastic culture system, unfortunately, our plastic culture strawberry cultivars seem to be susceptible to everything. But the Midwest Small Fruit Pest Management Handbook does have a table in there with resistant cultivars. So resistant cultivars will not be susceptible or as susceptible, so they're more tolerant to these kinds of diseases. Good drainage and good air circulation, very critical in fact, for all of your plant diseases, because the faster that we can dry those leaves out, dry that fruit out, the better our air circulation is, the faster we can dry it out. Then we don't have that water available. And our fungal pathogens need water to complete their life cycles. So the more humid, the rainier overhead irrigation, rainy seasons, poor drainage, anything that will give you water or humidity is going to be conducive for disease development, for spore production, and for dissemination and infection. We're mulching to prevent splash. So any splashing that's bouncing around and moving those spores, especially those overwintering spores. So keeping those plants up off the ground. Cultural practices is usually a primary means for disease management. We don't see leaf blight unless we see poorly managed production. And fungicides, we're applying those after harvest in rainy seasons, especially for commercial growers. If you have a small operation, you can probably completely manage this one with cultural practices. If you're a commercial grower, if you're managing other diseases, you're usually hitting this one. But still, leaf blight shows up as one of the top diseases in strawberry in Kentucky. But again, that's usually the result of poor management or poor sanitation. All right, another leaf disease, leaf spot. This one looks different from a plant pathologist's eye. These spots are scattered throughout the leaf. They remain very small. This disease, though, infects leaves, fruit, petioles, runners, even calyx tissue. So what that means, if you think about places or tissue that is susceptible to infection, consider, especially if you're a small grower, do you produce your own cuttings, or do you collect runners for increasing bed sizes? You can move this disease much more easily. So infection occurs early in the spring. or it can occur in the fall when temperatures are moderate. So moderate means not too hot, not too cold. Okay, so this is not a summertime disease. The drier and hotter it is in the summertime, the less disease spread you're going to see. This disease also overwinters in these spots. You see the spot has that purple halo, but that ashy gray center is where this pathogen is going to produce those fruiting structures. Fallen leaves or any infected tissue is going to be the point for overwintering. So just like leaf blight that I discussed, sanitation, keeping it clean, using resistant cultivars when possible, especially if you're in a matted row system, good drainage, good air circulation, so you can dry those leaves and plant tissue out as quickly as possible. That way you have eliminated that free water, as we call it, that is necessary for disease development. Mulching, always keep a really generous layer of mulch underneath your plants. Cultural practices, very important. Fungicides, if disease becomes severe. So again, commercial growers are usually managing fruit rots. Those same fungicides are usually sufficient. If you have a problem, though, you can target in particular, you can target these leaf diseases. If not, you should catch them with your fruit rot protocol. All right, the most important group of diseases in strawberry are the fruit rots, because we manage a crop all season, and a lot of these fruit rots will come in just as fruit starts to ripen. We can really easily lose fruit, or worse, we can get them to market and our customers will lose those fruit. The two big ones, anthracnose and gray mold. So I'll go through those. They're different, even though we'll manage them, a lot of the overlap in management. So anthracnose is caused by Colototricum species. This is a mistake, Colototricum acutatum, and some Colototricum gliosporoides. You don't have to know those species, but know that there are different species of the same genus. The anthracnose fruit rot can occur anytime during fruit development. It's most common, though, as fruit size up and start to mature. Stems can become infected, and there's also a a crown rot phase. We have evidence that it can be actually the same species. So not as prevalent, but it can be the same species. So we've seen that. Anthracnose fruit rot loves warm, wet weather right at fruit set. So think about what our seasons are doing. Fruit set is always rainy, right? So we very seldom have a dry spring here in Kentucky. Warm, well, that's another story. So if it's warm and wet, anthracnose will be very happy, and it will be very free to infect our fruit. The fruit turn dry and they'll turn black, and you'll see the concentric rings as infection spreads. The photo on the left is a image of a strawberry that was infected later in the maturation process, where on the right, those are fruit that were infected very early, either right at petal fall or very early. So those have not matured, whereas the one on the left was infected later. And that's usually what our growers are used to seeing. A lot of times we bring these Colototricums in with our plugs and with our runners. Once it's established in a field, it's going to stay in that field pretty readily. This pathogen overwinters in any debris. So any rotted fruit, any soft tissue that was infected, it will overwinter. And those overwintering structures will remain in soil for about 9 months. And this is one of the prime reasons we encourage you to rotate your fields. In a perennial system, you may see buildup from year to year, but it's harder to rotate, I guess, perennial fields. But once you do come out of production, rotation is very important. So if you skip a year and come back in, your Colototricum has disappeared from the soil. So that's 9 months is kind of our key target there. So we manage fruit rots with sanitation. I say sanitation all the time. Sanitation, remember, is being clean. Clean picking is very, very important. And Dr. Besson said that earlier in regards to the spotted wing Drosophila. But sanitation or clean picking is important with any of your fruit rots. So as you're picking, 2 buckets always. The good fruit goes into one and your diseased fruit goes into another, because you're moving that fruit out of the field. If you leave that fruit in the field, the fungus is sporulating, and those spores will move to healthy fruit. So so disease dissemination occurs when there's diseased fruit in the field. So get it all out, clean pick. Mulching to prevent splash, to keep water from splashing on fruit as much as possible. Any of your cultural practices like resistance, like rotations, like air circulation, all of those things absolutely critical. Keep your fruit off of the ground. As much air that can circulate around that plant and within those plant tissues, the better. This is one that we use fungicides for. If you want to save your crop, this is one that I would absolutely consider fungicides for, especially if your field has a disease history, or if it's a very rainy season right at harvest time. Disease will spread much more quickly. Remember, with this and with all of our fungicides are not curative. So we're always going to apply our fungicides before infection. We're using fungicides to protect our crop. We're not using fungicides to cure. So once a fruit is infected, it's going to, you've lost that fruit. So you're not going to cure it with fungicides. Okay, the second fruit rot, and this one you probably see even more than the anthracnose, is gray mold or botrytis. What we call it. Botrytis is everywhere. This is an endemic fungus. You'll see it on ornamentals. You'll see it in vegetables. You'll see it in a lot of cases. In regards to strawberry, this is a fruit rot that's really, really common, especially a fruit ripened. And as the picture, you'll see that fuzzy growth in the picture. Those are masses of spores, not individual, but masses of spores. So when that happens, your other fruit are at very high risk for infection. Gray mold is not an aggressive fungus. It's a very mild-mannered fungus. So it takes an overripe fruit or an extremely ripe fruit or a damaged fruit in order for that botrytis to get in and to infect. So again, that's where a clean picking comes in. Any damaged fruit needs to come out of the field ASAP. This is also one that we manage with fungicides earlier in the season. We're protecting the fruit early. The more it's raining, the more conducive conditions are for infection and for disease development. So the drier we can keep it, but if it's rainy, fungicides are absolutely critical. We're managing gray mold or botrytis with sanitation. Clean picking, absolutely critical. Good drainage and air circulation to keep those fruit dry, very important. Mulching, again, to keep your fruit dry. I'm repeating the same things over and over, right? That's I guess, an indication, if you will, an indication of how important cultural practices are. And this is one that I absolutely would use fungicides if you're a commercial grower, so that you can protect your fruit between bloom and harvest. This is one that you would put fungicides on. Okay, so the last group are the root and crown rots. Anthracnose, so you're seeing that word anthracnose again. Anthracnose crown rot in particular is what I'm referring to. And another red steel, which is a Phytophthora, Phytophtheras or oomycetes, or water molds as we sometimes call them. So let's start with anthracnose crown rot. This is the same group of fungi. It could be the same one that's on fruit, or it could be a different one. We see a lot of anthracnose crown rot in plastic culture systems. A lot of times when it's in fields, it's because it came with those plugs, unfortunately. So the crown becoming infected, that crown dying, and all the plant tissue above that is being starved for water and nutrients. So you'll see wilting and collapse of plants. The photo on the right, you'll see that dulling and that kind of drooping. That's where it starts. If you suspect crown rot, just cutting that crown right in half, and you'll see that red marbling in there in that photo to the left. That's very diagnostic of anthracnose crown rot. So I said a lot of this already, introduced in plugs and runners a lot of times. Warm, wet weather will spread this pathogen like wildfire, moving down the rows and through the rows. So a lot of times we will see, if it was a shipment that was infected, we'll start seeing collapse in the fall right after planting. And then as temperatures get cold, it'll stop, and in the spring it could start again. So as long as that weather is, the temperatures are moderate and there's rain, you'll start seeing you'll see a continuation of that of that disease symptom development. And the spores, or those structures, can remain in soil, in debris, for about 9 months. So if you're on a plastic culture system, rotation is much easier, and it's really critical. So we manage by coming in with healthy planting stock. So we've got to start with clean plants. And I know that's impossible. Every grower orders what they believe is clean stock, but having a reputable grower is a really important place to start. Good sanitation. As you start seeing a collapse of these plants, get them out of the field as soon as possible. We recommend pre-plant dips if you're on a plastic culture system. We always recommend pre-plant dips for commercial growers. And then fungicides, if you start seeing a few symptoms, we can use fungicides not to cure, but to suppress disease. And sometimes that'll buy us just enough time to get a harvest out. So that's, if you start seeing disease, then we will recommend a fungicide regime for drenching. And finally, red steel. This is a Phytophthora pathogen. Phytophoras are the water molds, or the oomycetes, that need water to complete their life cycles. We see Phytophthora primarily in wet soils or heavy soils. We always recommend raised beds when planting strawberries. So this is usually the result of poor site selection. And as always, with the damage and rot of any root, you'll see everything above it collapsing. So that's why we see wilting and dying. Once Phytophoras are established, so if they're allowed to sporulate or produce spores within the plant, if you don't get that plant out of there soon enough, you'll see a buildup of that pathogen in the soil. And those pathogens can survive 13 years is, I think, the last report that I saw. So being very careful not to bring those in. You'll see the picture on the left. You'll see just the roots are gray, brown, so just not white and turgid like they should be. And by cutting a root lengthwise, you'll see the steel is red, and that's diagnostic of that Phytophthora. So management, sanitation, get out any infected plants right away. Good drainage is absolutely critical. There are some resistant cultivars out there if you have a history of disease in the site. And then you could use fungicides as a drench to suppress, again, just to buy yourself some time to get to that harvest point. So I know I talked about a lot of those really quickly. My goal was not to teach you everything about the life cycle of all of those pathogens. But what I do want to focus on are some of the resources that you could utilize, that every grower, whether commercial or residential, should be utilizing. First of all, the plant pathology website, you see the photo on the left, the upper left, that's our extension website. So that is the Department of Plant Pathology. We have a lot of fact sheets and resources that are exclusively on this site for any agents who are on. A lot of these are not on the College of Ag's website, so they are exclusively on our Plant Path website. I do a lot of social media. I have my Facebook on the right. kyplantdisease.com will give you links to all those, and that's usually where we put alerts out so that our growers can know what we're seeing, what's really common, what they should be looking for. And most importantly, and Rick mentioned this earlier, is all of our counties have agents, have county agents, usually ag agents. Some even have horticulture agents. So utilizing those agents, they're a great resource for triage. They can connect to any specialist. They know where all of these resources are. They can get their hands on them really quickly. And if they think that one of your samples needs to come to the plant disease diagnostic lab, they can facilitate that. So always go through your agent. They're a wealth of information that you can't get anywhere else. So commercial growers should know them by name. And finally, I did want to point out, so if you go to our plant pathology website, a lot of those publications there, if you click fruit and then small fruit, you can come through a wealth of information. Dr. Besson mentioned some of these IPM scouting guides. We do have a strawberry scouting guide. To the right is the Midwest commercial fruit spray guide. We have some residential options on the website as well, but our commercial growers know this publication very well. So a lot of different resources out there, just a click away. And speaking of resources, this is on my blog. This started as a handout, and I posted it on my blog simply to have a landing page. This is the UK Extension resources for commercial fruit producers. We will also get you this link. It is a wealth of listing for departmental websites, newsletters, blogs, and any kind of links that you might need as a commercial grower or even a residential grower. So definitely check that one out above all. And post your comments. I will be very happy to tackle those at the end of the program.
Great. Thanks so much, Dr. Gauthier. Dr. Pfeiffer, if you want to go ahead and get your screen share started. Dr. Besson, we had a question come in. It said about lures for spotted-winged Drosophila. There are two types of spotted-winged Drosophila lures, high specificity and broad spectrum. Which would be best to use?
Can you hear me now?
Muted. Okay.
The ones I've used have been the broad spectrum because they seem to catch more spotted winged Drosophila. The downside is that you catch more of other things as well. So to tell you the truth, you're going to have to be able to identify the spotted wings from everything else, and the broad one is the most sensitive.
And one, I think, for Dr. Gauthier, are you aware of any organic, I assume that means certified organic, dips for protection or for encouraging root growth? I've heard of willow tea or apple cider vinegar.
No, we're very limited in the number of pre-plant dips that are out there. None of them are organic. I am highly doubtful that any of the teas or vinegars will be antagonistic towards the Colototricum pathogens or the anthracnose pathogens. As for encouraging root growth, I think that's a different question, but any pre-plant dips for anthracnose management, no, I am not aware of anything that is organic. I can look into that, though. I'll be happy to look into anything that would be OMRI certified. So I'll do that for you and report back if I find anything.
Great, thank you. So if you have other questions, you can either use the Q&A or the little chat box. Some folks have done that already. We appreciate that. And thanks again to Drs. Besson and Gauthier. And we're going to switch over now to the plant pathology, staying in the plant pathology world, but talk about vegetables with Dr. Pfeiffer. So the floor is yours.
All right, thanks, Brett. And I see that I have about 5 minutes. 5 whole minutes.
We can extend a little past. There's
okay.
no limitation. We can do that.
That was a little tongue in cheek. So this afternoon I took kind of a different angle to my section. I'm going to talk about sort of the dirty half-dozen diseases of Kentucky vegetables, and then I wanted to highlight two free monitoring resources for commercial vegetable growers for managing time-sensitive vegetable diseases. So I'm just going to jump right in there. The first diseases that I'll talk about occur on tomato. These are two fungal diseases, early blight and Septoria leaf blight. Both of these diseases together are the most common diseases of tomato in Kentucky. It's critical to remove residues from the previous season and maintain weed-free borders. In reducing pressure from these diseases, Both of these diseases initiate in the lower foliage and then kind of work their way up over the course of the season. They'll be more severe under rainy conditions. These two are typically well managed with preventative fungicide applications, and if you're familiar with the fungicide program in ID 36 on page 100, that fungicide program should give good control of these two foliar diseases. I recommend that folks initiate that no later than knee-high plants out in the field. There are a couple varieties out there with early blight tolerance. We don't have any true resistance to early blight available out there. And oftentimes we see our initial early blight disease pressure really flaring at fruit set during drier years and indeterminate crops. In wetter summers, we'll see disease flare earlier than that. But something about that stress on the plant at fruiting is I think is why we see early blight pressure, particularly then. To differentiate these two diseases, the early blight lesions, early blight is shown in the lower picture. Those lesions tend to become larger. They're usually surrounded by a chlorotic halo, and early blight will go to the fruit. Characteristic in these lesions are a concentric ring pattern, so almost like a target, where Septoria, those spots tend to stay smaller. Septoria does not go to the fruit. It only infects the foliage and the petioles. The centers of those spots tend to turn tan. The spot itself stays smaller compared to the early blight lesion, but you'll get many, many spots on leaves to the point where the plant basically will just kill off that tissue and you'll get an overall blight. Second disease I'll talk about is anthracnose. Anthracnose can occur in a number of different crops, vegetables, and in addition to fruit. So anthracnose causes us issues, particularly in cucurbits, legumes, somewhat less in tomatoes and pepper. On the fruiting parts of the crops, you'll see a circular lesion that has almost an orangish appearance, surrounded by brown. This will often be sunken. In tomatoes and pepper, we see anthracnose flaring up as those fruit are beginning to age as they're ripening. In cucurbits and legumes, again, as the fruit ripen, the disease tends to become higher in severity, but we'll see anthracnose lesions a little bit earlier in the season on the vining crops. It causes issues with us, particularly in cucumber and watermelon. Oftentimes where we see the first strikes from anthracnose are when those vining crops are roughly about an armful or a bushel basket full sized in the very center of that plant. It's really key to implement preventative fungicide applications. And again, I'd refer you to ID 36 if you want to take a look at our vining crops fungicide program there. That program will target and give decent control of anthracnose. There are varieties with resistance available to anthracnose, but in particular for watermelon anthracnose, recent race shifts suggest that some of the varieties that have resistance, that have performed really well for us in the past, may not perform quite as well if you've been utilizing those varieties year in, year out. So moving forward to pepper, by and large, our biggest, most influential disease of pepper is bacterial spot. This disease is particularly damaging under rainy conditions, and it's really tough when it causes defoliation. The defoliation basically results in plants with relatively few leaves, and plants without leaves are not going to be making fruit. Sanitation tactics will reduce some of the pressure from this disease. That's things like removing crop residues, choosing resistant varieties. There are a number of different races of the bacterial spot pathogen out there. I think at present there are 12 different races. There's resistance available to at least 9 different races currently. And so kind of the recommendation is to hedge your bets and choose a variety that has resistance to multiple different races of the pathogen. The bacterial spot pathogen can be seed transmitted, so only set plants that look good. And then in rainy seasons, repeated copper applications are basically what it's all about for managing this pathogen. And so that means copper applications on a weekly schedule. If it's very rainy, you could shorten that to a 5-day interval. But that's the primary approach to managing bacterial spot on pepper. Powdery mildew causes us issues in the vining crops. It's very common in cucumbers, squashes, and most particularly in pumpkins. In rainy seasons, we'll see the powdery sporulation occurring on the lower sides of the leaves. Under drier conditions, we'll see sporulation on the tops of the leaves. This pathogen, the pathogen that causes powdery mildew on the vining crops, does overwinter here in Kentucky, and so residues from previous seasons can have influence on initial disease pressure. We recommend choosing resistant varieties whenever they're available. In the vining crops, we really see powdery mildew beginning to become a problem in mid-July. In western Kentucky, that might be a week or two earlier. In eastern Kentucky, you might see it later in July. But really, July is the time point when you should start looking for and preventatively managing this pathogen. But I say that kind of with an asterisk, in that you should also consider how long you intend to go with that vining crop, how long you intend to pick it. Because if it's, say, a shorter season cucumber crop, you know, it may be in your best interest, it may be more economically viable for you, you know, to move on to other parts of your production at that point and not invest as much economically in some of the more expensive powdery mildew fungicides. That said, powdery mildew in pumpkin is extremely damaging, particularly for carving pumpkins, and you will need to be managing it intensively with fungicides really to get to harvest. And so here's a picture of what powdery mildew can do on pumpkins. I also show a picture of powdery mildew on peas here. So the picture of powdery mildew on peas is to remind me to mention to you all that powdery mildews can occur on many different crops, but they're caused by different species of fungi. In some cases, these species are even located in different genera. And so even though we may be seeing powdery mildews occurring on multiple different crops in the same area, it is extremely likely that those are caused by different species of fungi. And the reason that powdery mildews are occurring on both crops is because the environmental conditions have been conducive to powdery mildew development. And so that was what that picture of peas was there to remind me to emphasize to you all. But in the picture of the pumpkins, you can see the damage that powdery mildew can do to carving pumpkins, and you may say, well, what damage? The damage is to those stems, to those carving pumpkin handles, which can make up between 50 and 90% of the price that you get for carving pumpkins. And so even though powdery mildew does not infect pumpkin fruit, it is still very much worth it to manage that disease and manage it intensively in that crop. The next disease I'll talk about also in the vining crops is downy mildew. If we have any vining crops producers in here, you've experienced downy mildew. The pathogen that causes downy mildew does not overwinter in Kentucky. It's blown our way from areas with less challenging environmental conditions over the winter. What I would say to you all is start paying attention starting in July, if not a little bit earlier. Downy mildew will be worse during summers with frequent rain events. And this is a disease, again, systemic fungicides are really necessary to manage this disease effectively. And that's particularly the case with the long season vining crops. With downy mildew, you'll see the sporulation occurring only on the underside of the leaves, and the sporulation is dark as differentiated from the powdery mildew sporulation. So downy mildew will be dark gray to purple, bordered by the leaf veins and sort of angular in appearance. You won't see much besides angular chlorosis on the top sides of the leaves if you have an issue with downy mildew in the vining crops. And so again, that's a picture through roughly a hand lens of what the sporulation from downy mildew looks like. Again, that occurs on the undersides of the leaves of cucumber, watermelon, muskmelon, summer and winter squash, as well as pumpkin. And so that kind of shifts me over to the other thrust of my presentation, and that's to talk about monitoring resources. And I want to highlight 2 vegetable disease monitoring resources that you all should subscribe to. They're free. You can enter your specific farm location into these monitoring resources, and then by text or email, whatever you specify, you'll receive alerts when downy mildew, or later on I'll talk a little bit about late blight, when either of those 2 diseases are within proximity of your farm. And so the Cucurbit downy mildew IPM pipe is a monitoring resource. It's a network of plant pathologists all up and down the East Coast of the United States. As plant pathologists, we're monitoring for downy mildew to occur, and basically in real time, we put confirmed reports of downy mildew into this forecasting website. To use that forecasting website, I've sort of laid out a strategy here. The first step is to register for alerts specific to your farm location, and I recommend registering for the 500-mile radius. That website will be available in the resources list that Brett provides to you all. The second step is to implement the early season protectant fungicide program for the vining crops. That's that ID36 program. But I would emphasize to you all that while that program gives very good control over anthracnose and some of our other foliar fungal diseases, there are no downy mildew specific chemistries integrated into that program. And so I would consider that early season protectant in the absence of downy mildew pressure. So the third step is when you get the alert, then you visit this website to identify your individual farm risk. And so you can see screen caps that I put up from last year's monitoring resources. And so in the eastern United States, basically there's a meteorologist that works with our group to basically align the confirmed reports of downy mildew with the projected weather forecast over the next few days. And so these risk predictions are updated 3 times a week. The color indicates the level of risk that you're at. And so what I encourage folks is that if they're at low to moderate risk, I encourage them to at least apply a protectant fungicide. If you have very high value vining crops, or if they're a very important part of your operation, you may want to go with a downy mildew specific fungicide, even at low to moderate risk. Absolutely, if you're at high risk, I would recommend a downy mildew specific fungicide. And so in this way, we can save those more expensive systemic fungicide applications, basically save them for the period of time that we're at highest risk in these vining crops for developing downy mildew. And so I'm going to shift gears here toward a disease that we do not frequently get in Kentucky, but when we do get it, it can be extremely catastrophic for tomato and potato growers. And so this disease is late blight. Like the downy mildew pathogen, this pathogen does not overwinter in Kentucky, but they have late blight right now in Florida, actually. And so while we don't get late blight every year, when we do get it, systemic fungicide applications are absolutely necessary for efficient management of this disease. And so you can see, you can take a look at some of these pictures that are showing common late blight symptoms. Like the downy mildew pathogen, this pathogen also sporulates on the undersides of leaves, but it sporulates excellently on fruit. as well. This pathogen is benefited by frequent rain events and cooler weather. And so like the downy mildew IPM pipe, there's also a monitoring website for late blight, and that website is USA Blight. This is another free resource where you can enter your farm location and receive reports, confirmed reports of late blight specific to that farm location. And so here, what's shown is a screen cap. This was actually from 2013. That was the last time that we had significant late blight pressure in Kentucky. And so the counties where we had confirmed reports are colored in there. I think there's Allen County and a few others that are darkened there. But you can see the other areas in the United States that also had late blight that year. So what's the strategy when you're using this monitoring website? You want, again, you want to register for alerts, a 500-mile radius to your farm location. Again, implement the ID36 protectant fungicide program. That'll give you protection only. It doesn't have anything that integrates a systemic activity that will be effective against the late blight pathogen. And this is where the two strategies kind of diverge. The third step is when you get an alert for your tomato or potato crops, you want to go to the website to evaluate risk. So if it's within 500 miles, you want to apply at least a protectant fungicide before the next rain event. Definitely consider a late blight specific fungicide if tomatoes or potatoes are a very important part of your operation. And then what's slightly different about this is that there's a genotyping program. And so you want to check the most proximal identification of late blight, basically the closest location where late blight has been found to your farm, and check what the genotype is, because in genotyping these isolates, these confirmed late blight oomycetes, in genotyping them, that also gives an indication of whether or not we can use a metalaxyl based fungicide to manage them effectively. And so a common name, one of the common products that the active ingredient is metalaxyl is Ritamil. And so we know that there are Ritamil insensitive isolates out there, but in the recent past, our populations in the United States have all been Ritamil sensitive, and so Ritamil would be a viable fungicide option in managing genotypes that say that they're metalaxyl sensitive. And so that kind of wraps up my dirty half dozen talk. I wanted to mention just a couple of additional resources in addition to Dr. Besson's list. He really covered a lot of the vegetable resources. Dr. Gauthier mentioned the plant pathology disease fact sheets. That encompasses all crop groups, and so not just fruit and vegetables, but agronomic crops as well are included in there. And then one resource that hasn't been mentioned so far, but is one that's new as of last year, is the Veg IPM phone-in hotline. And so this is a phone-in hotline. It's not a live call to a specialist, but what it is a 5-minute message that one of the vegetable specialists has put together for that week. And so the goal behind this is to disseminate it, particularly to folks that aren't using the internet for communications. Included in that phone-in hotline message, there can be things like weather updates by region in Kentucky, emerging pests, emerging diseases, and then some of the summaries from our diagnostic labs. And best of all, it's free. And so this hotline is being paid for by our state IPM grant, and so please do utilize it. It's a free call for you, and it takes about 5 minutes. And so with that really wraps up my dirty half dozen talk. And so I think I'll stop sharing my video right now. And I welcome any questions that you all have.
So I think we had maybe a potential follow-up answer here to that, the root dip question that somebody had asked. And the answer here, you all can read it for yourselves in the chat box, but Regalia is an OMRI-listed fungicide that is registered for pre-plant application on strawberry. Regalia is an SAR, systemic acquired resistance, that kickstarts the plant's immune system. SARs are not fungicides, but protect plants through different means. There is no efficacy data available for Regalia on strawberry anthracnose. So that's a little bit of an answer, and there's a link that Dr. Goche just shared to her, that big kind of list that she had talked about on her blog there.